everybody can contribute in different ways, even if it's something simple like just testing the new release, right?
Yeah, I think maybe a lot of people don't realize how much maintenance software requires. Like, even if we were not shipping anything new, we would still probably be doing many, many hundreds of hours of maintenance work constantly. So like, have everyone heard of the book Working in Public by Nadia Iqbal? She used to be at GitHub, and she has like a few chapters on just software maintenance in general. And I think she estimated like 40 to 70% of all software projects, they just spend their energy, that much energy on maintaining it. And then we have a unique, I think beyond that, is an extremely high security risk, and the stakes are extremely high, because if there is a vulnerability, then that's like, $300 billion down the drain. And also, our scope is very large in Bitcoin Core. We have everything from like managing networking sockets to like a GUI, and like every single level of that, we have a pretty high bar in terms of security and like what's acceptable for us to be shipping to all these Bitcoin users and this Bitcoin ecosystem relying upon. And so I would say maybe like 80% of our work is just maintenance, and it's not easy. Sorry, that's my rant.
You're Andrew. You're actually live streaming on Twitch. You're coding, right? Can you tell us about that?
I was gonna say, to add on to what Gloria was talking about, like we have a lot of bug fixes. We have a lot of like improvements to just the software itself, not even to Bitcoin, just like wallet improvements, improve sync times, improve other various performance things that over time, as the blockchain continues to grow, the blockchain is effectively boundless. If we don't do these improvements, eventually it will take so long that like blocks will come out faster than you can ever catch up. Maybe. So there's always constant improvements, and yeah, on my Twitch stream, I do like go through them. I try to do code review. I also do coding, and I show people that there is ongoing work. A lot of it can be pretty boring. It can be also frustrating. There's a lot of cursing. But also like a lot of it is not protocol work. A lot of it is just like boring. There's a bug here, and you have to write a test. You have to test it manually, write a test. Find out that test doesn't work. Rewrite the test. Find out your bug fix doesn't work. Rewrite the bug fix. Things like that.
And then get your bug fix merged, and then realize you introduced a new bug.
Oh,
and
yeah,
then someone patches that one, and they accidentally introduce a bug, and it goes on and on and on.
You're definitely selling the quality of our product. RC2 for Bitcoin Core 24.0 was tagged earlier today, so if you're interested in helping getting the release out, you can start testing that now.
Besides that, it's one more than 23. What else is in 24 that you're saying about?
It has some really fancy stuff. For example, we finally have an RPC call with which we can empty wallets and send all RPC. Sorry, I'm showing my own badge here.
So there's a fun thing. We introduced it a while back called descriptor wallets, and the goal is to replace the old style of wallet. Now, it is unfortunately not backwards compatible, so the 24 has a migration tool to take your old wallet and turn it into a descriptor wallet. I'm pretty sure it works, but it would be nice to have more testing on that.
About descriptor wallets, so descriptors, for those who don't know, they're like a mini programming language to describe all kinds of outputs. Like this, you can just say the address is generated by this expub with Pieter's age wrapped segment or something. But it can also describe multi-sig constructions, and it was really invented so we can capture that generality, because the legacy wallet that Andrew was talking about, it was really key focused, and there was no clear path how that could be generalized to multi-sig. So the descriptive language has been in work for a while. They're now default. There's a way for migrating legacy to descriptors. And new in 24.0 is miniscript support, just watch only so far. So miniscript is a project that Sanket, Andrew, and I at Blockstream started a couple of years ago to extend even further and introduce things like, what if we want wallets, say, a multi-sig wallet where you need fewer signers over time because maybe someone lost their key, or all kinds of more interesting contract work that would be useful to end users even. And so miniscript project is a way to introduce that to descriptors, and watch-only support for that is implemented for that out.
And the cool thing about miniscript is that the smart compiler produces Bitcoin script that's more efficient than hand-rolling scripts. We have found, wasn't it like Lightning HTLCs was like a few bytes more efficient if you're using miniscript than whatever the Lightning spec guys managed to make by hand?
Maybe also to clarify, the output descriptors are extremely useful if you're trying to have a multi-device setup. Previously, many different wallets had different ways of representing extended pub keys, and getting multiple devices to speak the same language and to track the same wallet was not trivial. Now that we have an open standard that is implemented broadly, it's much easier to set up a multi-sig wallet and have different devices from different manufacturers be able to collaborate on a wallet. And tying in with that is also PSBT, partially signed Bitcoin transactions, which standardize not fully signed transactions as an export format that is able to translate between these. And now I think that will make it much easier to build multi-sig wallets in the future.
It's great when you do have hardware wallets or signing devices, like from different manufacturers, and you have using that for multi-sig, then you don't have to trust any one of them, right? So you need a way to move those partially signed Bitcoin transactions, PSBTs, from each device, right? And then this is a standard you created to do that.
Yes. So PSBT, I mean the original goal was for hardware wallets, hardware signers, and they contain all the information that is needed to sign a transaction, so that entirely offline devices can do that safely. Either they make an invalid signature, or they make a valid one, or they don't. And so it provides everything so that you can offline verify everything's right, or if it isn't right, then you're sure that you will never make something that accidentally sped you. So that's the design goal.
Before PSBT existed, really, especially if you wanted something like multi-sig across different wallets with different wallet software, you'd have all these individual pieces of information that would here's the unsigned transaction, and here's the script that this P2SH represents, and these are the keys that were used, and all this information was had to be passed out of band alongside the transaction for the other party to even be able to produce a signature, not even decide whether they want to sign it, just the information that was necessary. So PSBT was a standard device to just pack all of that into a single file or a single string, and these days it's getting adopted by more and more software, so that's great to see.
Like back in the day, and still today, if you are a hardware manufacturer, you wrote your own version of PSBT essentially that only worked with your software and only worked with your hardware wallet. So there was no intercompatibility. If you wanted to implement hardware signer support into a software wallet, you had to now use this proprietary thing. And so the nice thing about PSBT is it's an open spec, it's in a bit repo, it is effectively it is a standard. That's right. So it's great for compatibility, in that, all the other, even if you're not a hardware manufacturer, for software wallets, we all implement the same spec, we can also now interoperate with each other.
Yeah, it's all about open standards that are interoperable with each other, and then people have the choice of which combination of hardware and software they want to use. So it's the same, Bitcoin ethos spread over this. Does someone else want to talk about a package relay?
Where do we start? I think of package relay as like a bug fix, essentially, because we allow, since the beginning, since Satoshi, we've allowed you to create transactions spending unconfirmed outputs. And so we should have had package relay at that time, but we're catching up now.
Maybe explain what package relay is.
Okay. So package relay is a combination of mempool policies and mostly a peer-to-peer set of messages to allow nodes to communicate about sets of unconfirmed transactions rather than individually. So a package is any DAG of unconfirmed transactions, and where I'm explaining this terribly, where a direction between two transactions is a spending dependency. So if this transaction spends an output of another transaction, then it has an arrow pointing that way. So think of it as a DAG. It is any DAG constitutes.
Directed acyclic graph.
Yes.
We all know what it is, but
Sorry, I don't have this loaded. You go.
Okay, so if you have a transaction that has a very low fee rate and you want to reprioritize it so it gets confirmed more quickly, you might do something that we call a child pays for parent transaction, which spends an unconfirmed output in a new transaction with a much higher fee rate and then incentivizes miners to include both of those transactions. Because in order for the child transaction with the high fee rate to be valid, the parent transaction has to be included first. But the problem is that the parent transaction might have such a low fee rate that it doesn't propagate on the network by itself. So the new transaction, the child transaction with the juicy fee, might be propagating on the network, but then every node is like, I've not seen the parent, so what am I going to do with this? And package relay ensures that if we have such a set of transactions that are interdependent, that they travel together. So we basically introduce a new set of rules that we can not only send a single transaction to our peers by itself, but actually tell it, look, there's a whole group of transactions, they belong together, please consider them together.
right, makes sense. We'll do a Q&A at the end. Also, yeah, I think we've seen more that there's an increasingly adversarial environment, and for Bitcoin in general, right? So we have something like BIP 324, which my understanding is that it would encrypt traffic between Bitcoin nodes.
Yeah, so this is a proposal that Dhruv Mehta, Tim Ruffing, and I very recently published an updated version on. It's an old idea from, like, I don't know how many years ago, has a long history, but so indeed, the idea is we want to encrypt traffic between Bitcoin nodes, and the reason we want to do that isn't as clear. I mean, inherently, all data on the Bitcoin network is public. It's going to be published on the blockchain. When you broadcast a transaction, you don't expect privacy from keeping a transaction secret. But at the same time, there are things that actually are private. For example, where a transaction originates on the network. If we envision, global surveillance, a sufficiently powerful attacker that can spy on many connections, it is trivial to identify where a transaction is first broadcast, which has a relation to who is making it. Or, for example, discovering even links where Bitcoin nodes are or where blocks originate. On itself, that's not secret, but an attacker that, for example, wants to perform an eclipse attack on a miner, well, they need to know where they are. And this is information that well, we can raise the bar in how hard it is for someone to get this information. Encryption is not sufficient, and like this is not a full solution to that problem, because for starters, there's no authentication. Bitcoin nodes don't have any notion of identity. Like any node is just as good as any other, so we can't really talk about which one is the right one or bad one. So such a sufficiently powerful attacker can still man in the middle connections, or they can even just spin up their own nodes and observe traffic that goes through it. But the costs for doing something like that are significantly higher than just looking at what going through the connection. And so we're pretty excited to see that make progress.
And also when it's encrypted, then it can't be tampered with, right?
Yes and no, because there is no notion of identity. Like, you know, connecting to an attacker is just as good as connecting to another node. Well, what it does is it raises the cost for tampering. Like, if a node, you know, if the attacker manages to make me connect to them, they can still do everything. But by it being an encrypted connection, they can't just, you know, implement this on a firewall directly. They need to fully intercept the connection and forward it further. And this is just harder.
Right, like your ISP now needs to run a Bitcoin node in order to attack you. They can't just, you know, watch all your Bitcoin traffic flowing through their data center. They gotta do something in order to be.
And so something else the proposal does is, like, encryption is you know, for confidentiality of the data goes through it is the primary purpose, but it goes further than that. In fact, we try to even hide the fact that there's a Bitcoin connection there. That's a hard job, especially for now, given the fact that almost every node runs on port 8333, which is, you know, big wave A Bitcoin node here. That I think it is a default that will go away over time. There have been recently some developments in stopping the prioritization of nodes on that port, for example. So what BIP324 does is it not just encrypts data on the connection, it also achieves the fact that every byte through the wire is uniformly random to a non-active attacker. Right now, every Bitcoin connection starts with like the 4 bytes network magic, just 4 weird bytes followed by a version. So it is immediately obvious to anyone observing the traffic through it, yep, this is a Bitcoin connection. And so we want to get away from that and get to a point where, well, they might still be able to guess that it's a connection, but they need to operate on a whitelist basis. Like, sure, you know, the thing, if you get internet on a plane or on certain hotels, where they block everything but HTTP traffic, but that is much more observable to the user that, you know, there's censorship going on. And so we want to move to a model where connections aren't as readily detectable.
So maybe to sum it up, in the works is a new version format, a version 2 peer-to-peer messaging system, and it encrypts all traffic, and it also makes the bandwidth use a little smaller, and it makes general observing of all the Bitcoin traffic on the network more difficult. People that do want to do this actively have to try. It doesn't just fall out of regular observation of traffic anymore. With some caveats, and we're gonna also have some other improvements coming there.
But you can also run Bitcoin nodes on Tor.
Yeah, that's definitely true, and you know that's a great tool for privacy. But Tor isn't, you know, the tool that serves all use cases. For starters, you know, Tor comes with a significant reduction or significant increase in latency. Bandwidth requirements it's not that easy to get large amounts of Tor bandwidth. Tor is a centralized system that relies on the directory of onion nodes, and more importantly, like things like Eclipse attack protection on the network rely on effectively the cost of an IP address. Like IP addresses today have a certain value, and it is hard or the assumption is that it is hard for an attacker to get access to many different networks on the public IPv4 and IPv6 address. And some of our Eclipse attack protections rely on that. We use something like grouping IP addresses and connections. If you have many connections from the same group of IPs, then we might prefer a connection coming from a different group than from the same group, sort of enforcing a diversity, and that is due to this assumption that it is hard for an attacker to get access to much of it. Tor is completely uniform. Tor introduces it's not an IP address range, but an onion address range. But getting one address or a million addresses on it is equally expensive. And so Eclipse attack protection is much harder for nodes that are running on Tor only. And so we want something where all traffic is encrypted, not just those that can make those trade-offs for additional privacy.
And that's of course especially a problem because in the past, majority of all nodes on Tor was run by certain three-letter agencies.
Certainly possible.
And just to clarify, an Eclipse attack is when a node is being cut off from the current state of the network.
Right. An Eclipse attack is yeah, exactly that. Like an honest node is surrounded by attackers, so they don't even have a single connection to an honest node, which is for most operation of the Bitcoin network our goal. Which is that's a really nice property to have. It is sufficient for you as a node runner that you have one honest connection to another honest node, but your ISP can very easily subvert that. Like they can make sure that every connection you make is actually to a node of theirs. You have no way of telling.
And also on the topic, Bitcoin Core is adding I2P support, right?
Had it for a while already. There's at least 3 privacy networks that are supported by Bitcoin Core already.
Tor, I2P, and CJDNS. The CJDNS author will, I think, tell you that privacy is not directly the goal. It's a mesh network.
Okay. And also, GitHub itself, right, is owned by Microsoft, and we've seen that GitHub has essentially deleted entire projects, right? And then you don't have some of that history as well, right? So you still might have the code, but you don't necessarily have the comments as well as the accounts and the interactions between them, right? And with Bitcoin Core, we have people under their real names, and we also have people under pseudonyms whose identity is unknown. Do we have a plan for if GitHub decides that they don't want to host Bitcoin anymore?
Obviously I think we think about this. We have a page on our dev wiki about it. I think we've spent many hours discussing it, and there's mirrors of the repo and the conversations and stuff, but if you were asking for a concrete roadmap for transitioning out of GitHub, we don't have one, sorry. Yet.
I think it's unlikely we would unless GitHub does something seriously egregious, because it's a lot of friction, it's really hard to do that. GitHub's also a very convenient place to be.
It's a shelling point. A lot of people, when they start looking at open source projects, will create a GitHub account. It's easy to be found there. We get a lot of people just from the open source space. Like you just click another repository, fork it, clone it, and having your own solution does reduce the ease with which people settle in, because they're used to GitHub, they know how it works, they are familiar with it.
Yeah, GitHub is a social network, and it's a centralized social network, and centralized systems have a big advantage when it comes to networking effects. Like, so I believe that, you know, if GitHub starts doing something crazy, completely unacceptable, then like this will damage the project. Like, but I don't think that this is, you know, we'll move on, we'll find somewhere else. Like there's no reason that things can't move. There's a cost to pay there in, you know, because it is not about the repository as said already. It is, you know, this focal point of development where everybody can interact with issues and pull requests and whatever. And, you know, losing that would be a significant cost to pay, but I don't think it's, you know, catastrophic. And given recent developments, I think, you know, and this is already happening, people are talking more again about, well, should we have contingency plans, what can we do? And because the question is, well, if not GitHub, then what else? Something self-hosted is an obvious choice, but hosted by whom? For example, random cool ideas, if there were several organizations hosting some self-hosted GitHub GitLab environment with various mirrors, and, you know, one gets shut down, move elsewhere, but I don't really think such a setup exists.
Yeah, the hard part really is, it's very easy to clone the software, right? Every one of us has a full copy of the repository. We probably, among us, have the full set of the pull requests as well, but the whole comment history does not live in the code itself, it lives on GitHub. So there are some mirrors that also collect all of the comments, and you have to think that GitHub projects come in various sizes. Ours has over 27,000 issues and pull requests at this time, right? And some of these have hundreds of comments on an issue. So we're talking about millions of messages. It's just not quite your standard website repository.
Yeah, and I mean, there are dumps of all this data, but it's not like we can restore it somewhere else and, you know, move all of that over. And so
We do have some efforts, like within the code base itself, to have some history preserved in the commit history. So our merge script, for example, always pulls the description of the pull request. So even if we were to lose it, we still have motivation of why some change was made. We record in the commits themselves who act what and what their act comment was. And we also, I think we try to get people to write useful commit messages too. so that even if we were to lose all the history, all the issues and pull request history, there would still be things in the source repo itself that mention the motivations, that discuss the motivations of why things happen.
But looking back, I mean, Bitcoin Core development, and I think we need general comment about this discussion because I feel we're conflating things sometimes. We are all contributors to Bitcoin Core, and we're primarily talking about Bitcoin Core software. That is obviously not the only piece of software that the Bitcoin ecosystem consists of, and many of us are contributing to other things too. But we are talking from a perspective here, and many of these things apply to other projects, obviously, in more or lesser degree. So what did I want to say before I started on these tangents? I have completely forgotten.
Okay, also, people were recently talking about full RBF again. Sorry, go ahead. What do you want to say?
So, what I was going to get at, Bitcoin Core development, before it was called Bitcoin, has moved in the past. It used to be on SourceForge, and it moved in 2010. Of course, times were very different, and development on SourceForge wasn't as it is now on GitHub. It was largely controlled by Satoshi.
I mean, before that, even you would just send your patch by email to Satoshi.
Right. Still, we don't have much insight about what development was back then. So just as an
Because he'd merge it and
Yeah, this is pretty much like all I'm thinking about today. And I want to be fair in this discussion, so I nominate you as the devil's advocate when I'm talking about development, and just so we have a balanced discussion on here. So should we start by defining RBF and full RBF maybe? So the whole Bitcoin exists basically to fix double spending, right? Like that's why you put it on the chain and then you put the proof of work on it, it's to solve double spending. And then so the question is, again, we allow and confirm transactions, so like what happens if you have two that spend the same output? They conflict with each other, so you should choose one of them. There's a few different ways you can resolve it. One is you can just keep the first one you saw, or you can choose the one that gives more fees, which is more likely to be mined, and if you're a miner, you probably want that one. And so RBF is a set of policies to allow that to happen. And then full RBF used to mean something else, but now it means something different. Full RBF now means maybe I should start with non-full RBF. So non-full RBF is while you're deciding, you will check to see if the spender of this transaction opted in to say, hey, I want this to be replaceable. And then you'll do kind of if they didn't signal, then you'll be like, okay, then I won't replace it. And this was added because there are businesses out there that receive payments unconfirmed and then will then do something, right? They'll rely essentially on unconfirmed payments, which are not in the blockchain yet.
usually referred to as ZeroConf.
That's a bad name.
It's a bad name, but that's
unconfirmed. Yeah.
This is good devil advocate.
Yes, thank you. I appreciate that. And I think there's a place for that, right? You want some merchants to be able to, send out the goods faster when they receive it. There are use cases for not waiting 6 confirmations or 1 confirmation or whatever. And I think people may be under the impression that this policy of allowing the users to opt in is preventing replacements when you don't opt in. So full RBF is, regardless of what they signal, just take the one that is higher fee rate, which with some other contingencies. And so most protocol developers, it seems, are like, well, full RBF makes sense because it is the more rational thing to do. Like if you are a miner and there's more fees on the other transaction, why wouldn't you take it, right? Even if, the end sequence or whatever. And so therefore, another part of Bitcoin I think is like, we want to have the strongest possible security model with as few assumptions as possible, right? So if we only have to assume miners are economically rational, that makes sense. But if we have to assume like, oh, miners are gonna look at that sequence number and then respect it, so they'll forego these fees because they're trying to be nice to the users, that is, hopefully this is not controversial, that is a weaker security assumption if you are relying on that.
if I can project, that isn't even sufficient. Like, even if miners weren't actively going to, hey, there's a way for me to make more money, I'm just gonna do it. The non-RBF policy of I'm going to assume the first version I see is the one that's gonna make it in is not a consistent choice because, speed of light, the time it takes for messages to travel across the network, not everyone is going to agree about what is first. Like, that is the reason why the whole thing exists. Like, if we had a simple problem to decide what was first, none of this would be needed. There are documented ways in the past of, bypassing ZeroConf assumptions. Simply by, you broadcast it one version close to the merchant, and you broadcast another version close to miners.
Or just send it out of that directly to the miners.
Yes, right. So all of that contributes to really this assumption of you are able, like that, this first seen policy contributes to a form of security, is sort of a gentleman's agreement to reality, like,
So let me jump in a little bit. Basically, we want to find out which of multiple conflicting version is the right one, and that happens at the point when a block is mined. It doesn't happen before. So before that, a transaction is at best a payment promise. And there are some businesses that want to have a good UX, and that means that they are looking at how long has this user account existed on our platform, how likely do we think is the transaction going to confirm because it pays a high fee rate, it only uses confirmed inputs. So they rely on the fact that currently the majority of the network does enforce the first seen policy. They put up a ton of connections on the network so that if there were other candidates for this transaction being propagated, they would see them. So if they don't see any of that and the fee rate is high enough that the transaction will be included quickly and the customer is in good standing, they make the risky assumption that this payment will go through and offer the service to the customer earlier. So these Bitcoin developers saying that we should converge on the natural state of the network where we do not trust the unconfirmed transactions because they're only payment promises, breaks their assumption that they can rely on this. And for them, it feels then, of course, a little bit like an attack on their business model when these developers are saying, we're gonna push out a new flag.
But here's the thing is we haven't changed the policy at all.
Hey, I'm playing the devil's advocate.
You go, yeah.
So they're pushing out this new flag that allows people to replace transactions without even opting into replacement, and now we can't rely on anything anymore. So obviously we can't do cannot rely on unconfirmed transactions at all.
Off by default.
It is off by
So
default.
we're just getting short on time.
I was gonna say, even with the existing policy in Bitcoin Core, it is still possible to RBF transactions that do not signal. There are some people who run modified versions of Bitcoin Core that have this already, and they've run so since like 2014, 2013. It's not new that you could do this. It takes a little bit of effort, but like this was already a problem for those businesses. They were just kind of ignoring it, I guess.
No, they're exposing themselves only to a little risk. They don't only allow up to a certain amount of payments to be open at the same time. They are trading off risk for better user experience.
So yeah, we're running a little bit short on time here. I just wanted, yeah.
you're a good devil.
All right. Yeah. Does anyone want to ask any questions? And yeah, we can bring a microphone over. Mike.
Hello. Hey, one thing that was interesting that you mentioned was switching off the port from the 8333, and I'm not like really imagining how that would work necessarily, like what kind of network application interface there is in terms of picking ports and how that would work, or if it would be like Tor or whatever. Like maybe I'm actually kind of interested if you could elaborate a little bit more on that, because I'm thinking from like a infrastructure point of view, how do I, build that towards the future in terms of
Historically, the Bitcoin Core software and the software it descended from has had an extremely strong preference for choosing nodes that run port 8333. You've always had the ability to just configure whatever port you want to run on, but the default is 8333, and if you don't run on the default port, you're basically not going to get any connections from most of the honest software on the network. Ironically, lots of spy facilities do connect to everything, so if you run on an alternate node, you do get connections, but they're mostly not interesting ones. So this has recently changed in Bitcoin Core 23, maybe, that preference just doesn't exist anymore. Like, connections to any port that gets advertised are equally likely to be made. That is only a first step, and what the next step is that there are options. Like, first, we want to wait for that this there not to be much software left on the network, or at least have a significant portion of the network not have this preference anymore, because before that, running on a non-standard port is a... Okay, you want to...
Yeah, basically the idea is you, when you connect to the network, you first reach any Bitcoin node, and you will self-advertise your IP address and port through your peers. And then previously, if you were not using the default port, nobody would connect back to you, but now you can announce everything and you will get connections back, and you'll basically be able to have a range of ports or random ports or things like that.
Right, and so far the default is still 8333. Like if you spin up a Bitcoin Core node, it still runs on 8333. What the next step is for that, it's not for the short future, but it could be picked randomly, it could be, there's lots of options.
What do you have, question?
Yeah, it was, you guys were on the panel email, Peter Todd sent out an email talking about RBF. He has a service which does open timestamps, which puts a timestamp anchor in the blockchain, and he intentionally tries to RBF, non-signaling RBF events himself every hour. And he was just saying like, look at my dashboard, they're getting through. And so it's just like a data point from like now. That's it. Sorry, it's not a question.
Okay, check one more question, anyone? Okay, great, let's wrap it up. Thank you again to the panel, Daniel and Ameli.